This is ISCI 2001, Chapter 13, the Solar System. The main themes for this lecture are the planets, moons, and other bodies, including Mercury, Venus, our moon, Mars, Jupiter, Saturn, Uranus, and Neptune. A planet is an object that's orbiting the sun. It is nearly spherical, and it's large enough to clear all matter from its orbital zone, which means if there's something that's in its orbit, it's either going to pull it in as a moon, or its gravity will literally pull it into the surface of that planet. A dwarf planet is an object orbiting the sun that's also nearly spherical. It is not large enough to clear all matter from its orbital zone. This would be like Pluto. Small solar system bodies are all other objects orbiting the sun, such as asteroids, comets, and meteors. This is a picture of our solar system. This is not to scale. Basically, it's just showing you the order that things go in. Obviously, Mercury is the closest to the sun. It's Mercury, Venus, Earth, Mars. Then we have the asteroid belt. Then you have Jupiter, Saturn, Uranus, Neptune, and then further out is Pluto, Eris, and all of the Kuiper belt objects. You can also see that we've got meteoroids and comets in with this. Mercury is the innermost planet. It moves very rapidly around the sun. It is the smallest planet. It's only slightly larger than our moon. It moves around the sun in 3 months, making it have the shortest year of all the planets. It has very high temperatures and low gravity, and it's covered in craters like our moon. We believe that those craters are from when it first formed, when there were lots of rocky objects in space, and since it doesn't really have much of an atmosphere, there was nothing really to slow those meteoroids down, so they struck the surface of it. These are the largest moons and the smallest planets in our solar system. The only planets that are listed on here are Mercury and Pluto. All of the other ones are moons: Ganymede, Titan, Callisto, Io, our moon, Europa, Triton, and Titania. Most of those are actually planets that are not planets, but moons that belong to Jupiter. Venus is what we usually refer to in the sky when we see the morning star that appears near sunrise or sunset. This is actually not a star, it is Venus. It shines very brightly because it's covered with clouds that reflect about 80% of the sunlight that comes close to it. These clouds also cause a very, very harsh greenhouse effect, so it is very hot on Venus. It spins so slowly that each day is longer than its year. So it takes longer for this planet to spin on its axis than it does for it to go around the sun. And it also spins in the opposite direction than all the other planets. It's similar in mass, size, and density as Earth, but its environment is very hostile. And the majority of the landscape of Venus is mostly flat. This is a telescopic picture of Venus, and you can see on the right hand side what it looks like when it's beside our moon. So typically that very, very, very bright star looking thing in the sky at night, the brightest one is going to be Venus. So it's not actually a star, it's the closest planet to us. Our moon is the second largest, brightest object in the sky. The first largest, brightest object in the sky would be the sun. So it's the second one. It is our closest neighbor. It has no water or atmosphere on it. And various Apollo launches have discovered and observed many things, including, that there is no water. There are lots of craters. The surface of the moon is very powdery and dusty, and there is no wind on the moon. So the footprints that were left there by the Apollo missions, those footprints are still there. So unless something catastrophic or something hits our moon, those footprints will remain intact. Notable features of it, you have marias, which are areas of lower altitude filled in with dark solidified lava. These are the dark spots of the moon. Then you have your lunar highlands, which are areas of higher altitude that appear lighter on our moon. It has an abundance of craters. On the far side of the moon, there's an absence of marias, which means that there is no lava fields there, so solidified lava. So, which means as it is rotating around the Earth, our gravitational pull on it, it actually, while it was forming, our pull on the moon was so great that it pulled the lava just to that side. So on the far side of the moon, which we never see the far side, the only people who have ever seen the far side of the moon are those that were on the Apollo mission that had to slingshot around the moon in order to get back into our orbit. So keep that in mind. There's a whole side of the moon that you've never seen and that just a handful of people have. Here on the top left side, you can see the dark spots, which are the mareas, and then you can see the brighter areas. Okay, those are your lunar highlands, and this is the reason why they're brighter is because the sun reflects off them better. You can see the picture, the left-hand side at the bottom. We call this picture Earthrise because this was taken by an Apollo mission, and it was a picture of the Earth rising into where they could see it, kind of like our sunrise or our moonrise. This was their Earthrise. And then on the right-hand side, you can see a picture of Neil Armstrong with the first lunar landing and the footprints that he left there. And like I said, since there is no atmosphere or wind, those footprints will stay there forever. Mars is bright red in color. You can actually see, when you look out into the sky, you can see Mars. It's the only star-looking thing that you will see that has almost a rust tint to it, reddish rust. Sometimes it's a dull orange, but you can actually see it. It completely orbits the sun every 687 days, which is twice the amount of time it takes for Earth to get around the sun. It rotates on its axis every 24 hours, 24 hours and 37 minutes. So its rotation on its axis is very, very similar to Earth. It has 4 different regions that we call provinces. The first region is the volcanic regions with inactive volcanoes, and then you have a system of canyons, and then you have regions of terraced plateaus near the poles, and then you have flat regions that are pitted with impact craters. Now, Mars does have the largest volcano in our solar system that we've been able to have evidence of, so that's really cool. Here you can see in the top left-hand corner, you can see the polar ice cap on Mars, which means there is some type of water there, even though it's ice. It's frozen ice. You can see different craters on it. You can also see where it juts up. Those are the volcano regions of Mars. On the bottom left-hand side, we call this the man on Mars, or the face of Mars. What this is it is actually a volcano, and it was just the way that the sun was hitting the volcano when that picture was taken that made it actually look like a face, but it does look quite eerie. On the right-hand side, you can see impact craters, and then the rocky region, the part that looks rocky, those are volcanic regions. So those are actually volcanoes. Jupiter is the largest planet, and its mass is equivalent to 318 Earths. That's how many Earths that you could fit inside of Jupiter. And it takes 12 years for one complete trip around the sun. So 12 of our years equals one of their year. It has low density because it's made mostly of hydrogen and helium. And it does have bands around Jupiter, which indicates different types of elements in its atmosphere. It has 39 satellites, which we call moons, and 4 can be seen from Earth, and those are the Galilean moons that can be seen from Earth. Those are Io, Europa, Ganymede, and Callisto. These are the pictures you can see on the left-hand side of the banding around Jupiter, and like I said, this is caused from different elements that are inside of its atmosphere. You can see the large red spot on both of the left-hand pictures. That's actually one huge storm system that never goes away. It's like a hurricane, basically, that travels around Jupiter and always stays in that banded region. On the right-hand side is a computer-generated picture of Io, Europa, Ganymede, and Callisto. Those are 4 of the Galilean moons that we can see from Earth. Saturn is slightly larger and less massive than Jupiter, but it has a very unique, beautiful system of rings. Bands made of thousands of particles that range in size from dust to several meters across. It has the lowest density of any planet. Scientists like to say that if there was a bathtub big enough to fit Saturn in, that it would float, kind of like a beach ball on top of the water. That's how the density is so low of Saturn, it would make it do that. All right, these are the top left is top left and the top right are actual telescopic pictures that were taken with the Hubble Space Telescope. The bottom two are computer generated. You can see on the bottom left the moons that travel around Saturn. On the upper right, you can see the different rings and the divisions, and basically we just have A ring through G ring, and then you have two different major divisions in it. At the bottom right picture is a picture of what we would suspect the rings would look like close up, and it's not going to be just rock. It will be dust, it will be ice that go around it, because it is very cold in that region of our solar system. Uranus is very large. It takes about 84 years to circle the sun once. We don't know a whole lot about Uranus because it is so far away. We do know that its axis is tilted extremely. Instead of just having a slight tilt to it, it's almost on its side. And we do know that it has rings. Here's a picture of it, and this is a computer-generated picture. You can see the rings that are going around it, and you can see how tilted it is. It's basically just kind of laying on its side. Neptune is very large also. All of these planets that are past Mars, we call them the gas giants because they are composed mainly of gas, and they're huge. So that's why we call them the gas giants. It takes about 165 Earth years for one complete orbit around the Sun. Uranus and Neptune are similar to each other in size and composition, and each have low temperatures due to their great distance from the Sun. This is a picture of Neptune. It's so beautiful, the blueness of it, and that blue is created by the elements that are in its atmosphere. It's not created by water. There is no water on Neptune. So once again, here is a picture of the solar system. Again, it is not drawn to scale. You can also see a planetary nebula down at the bottom. The right-hand side, you can see a comet that is going around the sun. This is a picture of where you can actually find some of these moons and planets, so that you'll know that they are actually not all of them are stars. Some of them are stars. At the bottom left, you've got Rigel, Orion, Betelgeuse, Gemini. Those are all stars. But you've got planets, which are Mars, Saturn, Venus, Mercury, and Jupiter. Those are all planets. They look like stars. We call them stars in the sky, but they're actually the planets. All of the words that are in blue are going to be your larger stars. The words that are in the pinkish color, those are going to be your smaller stars. And once again, now we cannot all the time see all of the planets like this together because of their orbits. Depending on where they are in their orbit will depend on where they are in our sky. Sometimes when they are in the orbital position that we would be able to see them, it's actually during the daytime, so our sun is brighter than all of the other bodies around us, so you can't actually see them during the daytime. But you can see Jupiter on the left-hand side, Saturn in the middle, close to our moon. Then you've got Mars, Venus, and Mercury. So the GPS standards that we covered were the ones for the lithosphere. It was just one standard today. We were able to demonstrate an understanding of the stars, planets, and the solar system. I look forward to seeing y'all on Wednesday, where we will be doing the laboratory experiment on longitude and latitude. Please read over that before you come to class. Also, do not forget to go and to Georgeview and do your quiz. and your discussion topics. And I will see you on Wednesday. I hope you have a great day. Bye.